We're dropped into the conductor console and we can see a cluster connection has already been created. This cluster specifically is an Azure Kubernetes service cluster and has 3 Dapr-enabled applications running on it. Let's take a look at the 3 applications running on the workflow cluster connection shown in the conductor console. First is the checkout service. This application uses the Dapr Workflow SDK for .NET to kick off a checkout process. The input is a basic customer order, including the product for purchase and the desired quantity. The Dapr sidecar is responsible for managing the workflow execution, which includes keeping an append-only log of all activities and steps executed as part of the checkout workflow. Let's take a look at a couple of the other applications which the checkout service interacts with as it coordinates the order checkout process. The checkout service uses the Dapr PubSub API to publish messages regarding the status of a given checkout. A declarative subscription then ensures all of those messages are delivered to the notification service, which is written in Python and hosts a simple event viewer frontend written in JavaScript. In addition, the checkout service also makes use of the state management API to determine if there is sufficient inventory to fulfill the requested order quantity. If there is sufficient quantity, the workflow includes an activity which uses the Dapr Service Invocation API to call a payment service, which will mock processing the payment, returning a success or failure to the checkout workflow. The payment service uses the configuration API to retrieve a configuration item, which will determine if the payment should return successfully or unsuccessfully. This is useful for demo and testing purposes. In the conductor dashboard, we'll see 4 Dapr components: one for the workflow state store, one for the inventory state store, one for a message broker, and one for the configuration store. Conductor can also provide visibility not just into the components that are running within a cluster, but also things like, is the component successfully initialized before being loaded by Dapr-enabled applications? Are there any fatal log issues related to the component, or potentially metrics issues? This could be anything from component error rate to even application metrics, which are indicating that your application may be trying to use a component that doesn't exist. There are also high-impact advisories, which provide recommendations and best practices for configuring components. And last but not least, resiliency insights. This is extremely valuable as Dapr resiliency policies are encouraged in production. If for whatever reason your PubSub broker becomes unreachable, the resiliency will kick in and you'll be able to get insights into the fact that that resiliency policy is currently being enacted. We are now back in the conductor console looking at our cluster connection. If we navigate to the cluster level components tab, we can verify that the 4 components running in our cluster are visible. We can also head over to the applications tab and select the app graph. When doing so, we can see the activity across the solution at a high level. If we isolate on a specific app, for example, the checkout service, we can see not only the application interactions, but the components being actively used along with recent metrics. If we navigate to the checkout service application, which hosts the workflow, we can see it's actively using the orders component, which is the PubSub broker backed by Redis streams for publishing messages to the notification service, and the state store component for managing key value pairs for inventory. Currently, these components are both backed by the same Redis instance, which we can confirm through the connection manifests. With the applications and components both healthy and load being generated on the applications, let's make a couple of isolated changes to exemplify how Conductor makes catching operational issues related to Dapr components much easier. As you can see here, we have 3 components that rely on Redis, and all of them are expecting a Kubernetes secret called Redis password. Let's see what happens if we update the Redis password in Kubernetes to an invalid password, leading to failed component authentication. First, I deleted the existing valid Redis password. Then I passed in a value I knew would be invalid. Upon returning to the Conductor console, we can see all 4 components failed to initialize. This is due to the invalid username or password, which we can confirm by viewing the raw manifest. You can also navigate to the cluster dashboard under the Component Insights section to see the initialization failures. Let's look at another interesting infrastructure scenario. Here we can see the checkout service appears to have issues that have been detected. If we click on the metrics issue, we can see multiple alerts have been fired in the past couple of minutes, specifically one issue related to component errors. Clicking in on the source graph shows the application is not successfully storing inventory state. This is an indication something's occurring with our backing infrastructure. If we navigate to our backing Redis instance, we can see the database is essentially completely out of memory based on the current data plan. Returning to Conductor a few moments later, we see the initialization checks are no longer working, indicating the components are having trouble connecting to the backing resource due to the max connections reached. If an operator wanted to dive deeper into the cluster, they could confirm these findings looking at the Dapr and app logs for the checkout service. Dapr shows workflow state is failing to save, with an error typically caused by a Redis instance reaching its maximum configured memory limit. The application logs, on the other hand, also confirm that inventory state is not being properly saved, which is triggering the resiliency policy on the backing state store. If we look back in Conductor, the pub sub component is also now showing signs of failure, as it relies on the same Redis instance. We can also confirm that Conductor is showing activity with the resiliency policy on the state store and the pub sub broker. In this case, an operator could notify the backend team they need to increase the size of their Redis database. Now let's try a new example where we swap out the pub sub component used by the checkout service to an Azure service bus from the current Redis instance. Here we see we have a new component deployed on the cluster and also a Kubernetes secret to ensure that the component can connect to the service bus. Next, we'll update the Kubernetes manifest for the checkout service, passing in the name of the new pub sub component, which should be used when making publish calls. Once these changes are made, we can apply the new checkout service manifest to the underlying Kubernetes cluster. Lastly, we'll update the existing Dapr subscription to point at the new pub sub component so the notification service receives the messages. Once we've rolled out the applications and sidecars to load the new components, we can generate load and test the new component. We can see the messages are successfully flowing through the service bus topic notifications to the subscriber, which is the notification service. You'll see here the notification service is receiving and displaying the checkout status updates as new workflow instances are started. If we navigate back to the Conductor dashboard, we can see the new component is visible and marked as active. The component metrics indicate no current component failures with use of the new Azure Service Bus instance. We can also navigate to the notification service. We can see here that the Service Bus pub sub component is active. We can also see the requests per second show that the messages are successfully being delivered. Let's see what happens if we actually delete the backing namespace that's driving the Azure Service Bus component. One of the first things we can see is a spike in resiliency metrics. The checkout resiliency policy includes an inbound retry and circuit breaker policy on the service bus pub sub component. The retry policy, which is set to retry forever, and the circuit breaker, which kicks in when at least 5 successive calls fail to the backing broker. When we explored the critical issues that have been detected in the checkout service, we can also see a list of all of the metrics and logs notifications firing since the source went down. With the namespace deletion occurring at around 9:11, we see the error rate spike as early as 1 to 2 minutes after the resource was removed. Dive deeper into component insights using Diagrid Conductor.